unless it's server-side generated stuff. If for some reason you're generating a bunch of garbled HTML or a bunch of other things from the server side, then you can use some of the stuff that we'll talk about here in just a couple minutes to dig into that and see why it might be taking the case. But in the end, with ASP.NET, if it's generated content size or images or payload, you're going to have to look at something else, and it's typically more manual. Fiddler, though, is probably the best thing out of all of those to use, and it's free. It even works over HTTPS traffic and things like that. Just be careful, a word of warning if you've never used Fiddler before, make sure to turn it off as soon as you're done, because you try to do anything else, Gmail, for example, completely freaks out if you have Fiddler turned off. You cannot access your email accounts or anything like that. And I will admit that I have been locked out for a while before.
But we did use HTTP compression to improve the page size.
Yes, and you can take it, and HTTP compression would be another way.
But it did not really have a lot. What we did is we had to upgrade the hardware in order to have the product run, have the application run on the application server. So we have only one CPU, one processor. So we add 3 more CPUs.
And are you seeing resource constraint on the server side?
No.
Okay, it's just the page size. And then that's one of the scenarios where probably throwing hardware at it will not result in any difference.
Exactly. We add 3 more processor, which is total 4 processor, and we still see the page size really not.
Is it a publicly accessible URL? The application that's a problem. Is it something publicly accessible, or is it internal to your network?
It's just internal, not public.
Come see me when we're done. I'll show you a couple things real quick before.
Which is good because we have a release. This product will launch next month, and I really we upgrade the hardware, but it is not a long-term solution, but we try to talk to the vendor how to improve the product, but they couldn't figure out how to fix the problem unless they have to rewrite the entire application again.
That's not typically what you end up needing to do, but yeah, let me talk to you afterwards,
sure.
and I'll give you a couple other ideas.
Okay.
So the other piece of this, obviously, is looking at that code performance perspective. How long does it take for each line of code to execute? How often is it executing? Does all of that make sense? Now, there are tools to do this in some ways within Visual Studio. Some people may disagree with me, but the Visual Studio tools just don't work. They don't do a good enough job to get what you need to get done from a performance perspective. ANS Profiler is a product from Redgate. They offer tools for performing analysis of both memory use and overall code perspective, how fast does it run, etc. The pricing should still be correct. It's around $7.95 per developer for the full product. Again, they aren't paying me to be here, but I will say if anybody's interested in ANS Profiler, contact me if you want to get a license. I might be able to get you guys about a 10% discount off of their regular pricing, just because I do work with the Redgate team quite a bit as a user of their stuff. They do have a 14-day free trial, so if you've never played with performance profiling with code, I strongly recommend just go download ANS Profiler, install it on your machine, play around with it a little bit, see what it can do, see what your applications look like and the data that you get out of it. Biggest thing that you can do with it is you can profile any .NET assembly. They're also now giving you the ability to track the performance of your SQL and file system I/O. So if you're going off to SQL Server and it's taking 25 seconds, it can actually accurately trace that .NET stopped processing at this point, SQL Server was processing for this amount of time and came back, and then continued on from a .NET perspective. The nice thing about that, you have a database call, we look at the profiling results and it shows that it executed for 30 seconds. Well, was that 30 seconds of SQL Server chugging, or was that 10 seconds of SQL Server chugging, 20 seconds of the .NET code prepping things, and then sending it off? They get away around some of that as well. From a memory perspective, you can profile the entire expanse of what is in memory from a .NET managed memory perspective. The memory profiler tool, I'm not going to talk about specifically tonight because it is a beast. You have to really know what you're doing to go spelunking in there, because you see every single item that is declared in memory. So if it's there to support the .NET runtime that's spooled up with your application, it's in there, you can see it. So you have to really know what you're looking for to be able to do it. The biggest thing is you can also use this in production environments. So if you absolutely have to, you can take ANSYS Profiler and run it on a web server, attach it to a running ASP.NET 4 web app, profile traffic, detach it while the application is still running, not kicking users out. Users won't see much of any impact as you're doing the profile. On average, when you hook ANSYS Profiler up, visually to the user, you'll see about a 2 to 3% hit in performance, what I've seen from the stuff I've profiled before. It's smart enough to know the impact that it has on the application as well. So it adjusts all of its timing numbers, taking into consideration the overhead that it introduces. So in the end, you can get a lot done. There's going to be a new release that they have as well that allows it to just kind of sit out on your web server and run all of the time in production, constantly profiling, and it's just there whenever you might need it. Do you have to be built in the rest of it? You can, if you have a release build with a PDB, you can get pretty detailed, i.e. you can get down to the method level. To get to line level, you do need a debug build. So doing it against a release build, in a lot of cases, will get you in the neighborhood. What I typically do is if you're to the point where you're having to performance profile against a release build, you have a pretty big problem. So normally, method level is going to get you to at least where you can start to go and recreate it against a debug build later. There are other sneaky scenarios you can swap things around. You can take a debug PDB and drop it in there, and it actually somehow, for whatever reason, gets even more detail in there. But you do at least get detail of it. The only thing you can't do is obfuscated code. Obviously, all of your stuff, it's just not going to happen. So release build you can, but it's just not quite as detailed, and it'll kind of give you a little bit of a rundown when you look at the results as to what wasn't able to be profiled. So this is just kind of my quick hit as to why I use ANSYS over Visual Studio. One of the other tools that's out there, JetBrains has a tool as well that does stuff similar to this. I can't think of what it's called at the moment. But basically, the biggest thing is line level timing, is being able to profile things that are running, and the reports and everything are there. And again, it's not tied to a specific version of Visual Studio. I have people that are still using Visual Studio Express that have ANSYS Profiler licenses because they want to be able to do this kind of code analysis. They're not going to get it through Visual Studio, especially with Express editions. So I was trying to come up with a good example to give you guys, to give an overview of what ANSYS Profiler results might look like. Real applications are great. The problem is there's so much other junk with it that it's not as easy to explain to you why there's a performance issue. So this is my new go-to fun way to prove performance and performance-related issues in .NET. We have two methods. One does string concatenation 100,000 times. The other one does the same 100,000 concatenations but uses a string build. Now, everybody should know, I hope, one of these methods performs a lot faster than the other. And I hope nobody says string concatenation, because it's not. But one of the things you can do is, if you need to prove that, right, one of the things you get into in a lot of situations where you need numbers to back something up. So that's where ANSYS Profiler can step in. We go to test harness. All that test harness does is calls the string concatenation method, calls the string builder method, and then it waits for you to hit enter to exit out of the application. To hook it up, to do all of the testing, we start ANSYS Profiler. We're presented a screen like this. It's pretty simple. Up at the top, we choose what kind of application we want to profile. Do we want to profile a .NET app? ASP.NET app that's hosted in IIS could be, anything out there. ASP.NET application that's on using the web development server. It has full knowledge of Cassini and will be able to spool up a copy of Cassini and run your web application for you as well. You can work on Silverlight 4 browser apps, Windows services, Complex servers, and XAML browser apps, or attached to any existing running .NET process as well. Now, one note, are any of you guys Silverlight developers? Okay, those of you that are Silverlight developers, due to the protection levels in Silverlight, you do not get line level timings, no matter what you do. There's no way to do it. According to the folks at Redgate, there's something with the Microsoft security model with Silverlight that doesn't allow them to inspect in that far. I've been told by both Microsoft sources and Redgate sources that the next version of Silverlight might actually change that. But as of Silverlight 4, you still can't get line level timings. Do you know, does the Visual Studio Tools give you any ability?
Yeah, it's pretty ugly. It's pretty much attaching manually or something.
Yeah, I thought it was the same. Silverlight is the only one that I know of that still just doesn't have a good performance profile process. Now, granted, you're going against WCF services, and if it's the services layer, you can hook this up to it.